Okay, today we will be looking at section 1.8, the first part of this section dealing with inequalities, and specifically today we'll be looking at linear and polynomial inequalities. I will say in this section, if you are planning to take calculus, whether it's business calculus or calculus 120, you are going to see this a lot. So it's a very important concept that you understand. So this is something that you will definitely be transferring over to calculus if you take this course later or take that course later. Okay, some of our rules for inequalities, I'm not going to go through all of these because these are a bit abstract. We're going to look at it more through examples. The main thing that you need to remember with inequalities is that if we ever have to multiply or divide each side of an inequality by a negative number, then we have to reverse the direction of the inequality. I just wanted to show you just with a regular inequality, we know that 3 is less than 5. If we multiply that by a positive number, multiply everything by a positive number, then we get 6 is less than 10, which is a true statement, and that's fine. If we multiply it by -2, then we have -6 is compared to -10, and -6 is actually greater than -10. So we have to change that inequality in order to make that into a true statement. Okay, on this one, I want to look at just practicing some of these linear inequalities first of all. With a linear inequality, you're basically going to do everything just like a regular equation, except if you have to divide by a negative, then we're going to switch the inequality sign. So here I've got this equation that I'm going to solve. So I need to subtract 9x from each side, and we've been doing things like this a lot. So -6x would be less than 4. We'll need to divide by a -6. And at this point, when I divide by that negative, that's when I need to switch this inequality from being a less than to a greater than. Then we're going to reduce this. So it would be -2/3. So a lot of your directions are going to ask for this to be an interval notation. So if I were to write this in interval notation, sometimes it's actually easier to look at the graph in order to write it in interval notation. So -2/3 is going to be somewhere about here. It doesn't have a line underneath it, so it's going to get an open circle. And we want it to be greater than, so I'm going to shade in this direction, shade my arrow to indicate that it goes on forever. So this would be my graph. So as far as writing the actual interval, it's going to go from -2/3 to infinity, and this would be in interval notation. We want to put the parenthesis here because it does not have that line and it's not a closed circle. Okay, you have some compound inequalities that you also need to be able to solve. When we're solving a compound inequality, this one is still linear because it's to the first power. What we want to do is we want to get x by itself here in the middle, okay? So we want to remove everything else around the x here. And we would do that basically following the same steps that we would if it just had two parts to it. So we're going to get rid of this -2 first. So that means we're going to add 2. We also have to do the same thing to all 3 parts this time. So 4 plus 2 is going to be 6. We're going to be left with 3x in the middle. And then we're going to have 15. Okay. So we're trying to get this x by itself in the middle. So we're going to divide by 3 to do that. So 6 divided by 3 is 2. Here we have an x. And here we have 5. So this is telling me it's all the values between 2 and 5. 2 is included and 5 is not included. So I'm going to come down here. I'm going to put a closed circle on the 2 and an open circle on the 5. And again, that's because it doesn't have an equals sign underneath. And then I'm going to shade everything in between. So as far as my interval notation, it's going to be bracket 2, comma 5 with the parenthesis. Okay, here's a compound inequality for you to practice with. Okay, this is the answer that you should have gotten for this practice problem. Again, we want to try to get x by itself here in the middle. So in doing that, we want to remove the constant away from it first by subtraction. That leaves us with a negative 2x in the middle. We're going to divide this negative 2 away. When we divide by the negative 2, we need to make sure we remember to switch our inequalities. So instead of being a less than, this will become a greater than. This one will become a greater than or equal to. So when I look at this, typically we work from left to right. So we're used to working with the less thans, less than or equal to signs. So this one is reversed. So basically it's if I would recommend going in and turning this around. So we would have 9/2. We still need it to point toward the 9/2. So it's going to point toward the 9/2 here. And then it needs to point toward the x. So when I turn it around, this is what it looks like, and that makes it a little easier for us to graph. 9/2 is 4.5, so I've come over here at 4.5 and put a closed dot and an open one at 5 and sketched in between, shaded in between there. So this is the interval that we should have for this one. Okay, moving on to solving nonlinear inequalities. Specifically for the rest of today, we're going to be looking at polynomial inequalities. So these are those that have squares in them, and we're going to have to work with factoring and using cut points and so forth. So I have a whole list of steps that we're going to be going through. But just keep in mind, if we have the product or quotient has an even number of negative factors, then the value is going to be positive. And that's just saying like two negatives multiplied together give us a positive. Three negatives multiplied together gives us a negative. So we're going to be using that concept quite a bit here as we go forward. So this is this list, and it is kind of a long list that we're going to go through. We're going to do several examples, so I think you'll understand these steps as we move forward. The first one says move all non-zero terms to one side. So because these are going to be like quadratics and polynomials, you want to get 0 on one side and everything else on the other side. Factor if possible. And then we want to find what's called our cut points, and we find those by setting each of the factors equal to 0, and those become our cut points. The cut points are actually going to determine the intervals for us. Within each interval, we're then going to choose a test point. We'll plug the test points into each interval that's into each interval that we have. Determine whether the intervals are positive or negative. We're going to choose the appropriate interval, and we're going to choose the positive intervals if it's greater than or equal to. We'll choose the negative intervals for less than or equal to. Write your answer using interval notation to represent the chosen interval, and you'll use the union symbol to join those. And then last, be sure that you are correctly including the endpoints, brackets if the endpoint's included, and parentheses if they're not included. So this is a long list, but keep it in front of you as we go through these examples, and I think you'll see kind of how it flows as we go. Okay, so I've kind of included that list over to the side so that we can follow along and watch it as we look at this example. So the first step is to move all non-zero terms to one side, and that's what we would do anyway, even if this were just an equal sign. Because it's a quadratic, we need to get it basically equal to 0. So in this case, we're going to do x squared, move the 5x over, and move the 6 over. Okay, so we have it so that our non-zero terms are on one side. We want to factor if possible. So when I go to factor this, I need the what multiplies to give me 6 and adds to give me 5. So that's going to be 2 and 3. Okay. So we want to find the cut points by setting each factor equal to 0. So I'm going to take my factors and set those equal to 0. So I'm going to get 2 and 3. Okay, so these are going to be my cut points. Right, so with the cut points, what I'm going to do is I'm going to put these on a number line. So I'm going to put 2 and I'm going to put 3. The reason that they're called cut points is because they literally cut our number line into intervals here. This first interval is going to be the interval from negative infinity to 2. This one's going to be from 2 to from 2 to 3, and this interval is going to be from 3 to infinity. So it takes and it breaks the number line up into these intervals. Okay, so we've determined our intervals. Now we want to choose a test point for each interval. So a test point is just a point within this interval. So I just need to pick any number, nothing specific about it. I would say choose numbers that are easy to work with, like 0 and 1 if they fit. If they don't fit, then you'll have to choose something that might not be quite as nice. Here we can choose anything between negative infinity and 2. So I'm going to pick 0 as my test point for this one. Here I need to pick a test point between 2 and 3, so I'm going to pick 2.5. I can't really pick a nice one there. Here I need to pick something between 3 and infinity, so I'm going to pick 4. And it's going to work the same if you'd picked 5 or 10 or whatever. It's going to work the same for us. So we want to next plug the test points into the factored inequality. Okay, so what I'm going to do is I'm going to take these factors that I have here. So I have an x minus 2 and I have an x minus 3. I'm going to list those down the side so that I can work with this. Okay, so if I plug 0 into this first factor, 0 minus 2 is negative 2. I don't really need the number. I just need to know if it's positive or negative. So that's going to be negative. If I plug 0 in here, 0 minus 3 is also negative. Okay. So that means x minus 2 times x minus 3 is going to be a negative times a negative, which is going to give me a positive for that interval. So this is what I'm really going for. This is the answer that I'm looking for here, is that this is a positive interval. Okay, I'm going to do the same thing with the 2.5. So for this interval, my test point was 2.5. So I'm going to go over and I'm going to plug it in here. So 2.5 minus 3 is a positive 0.5. So again, I don't really need the number value. I just need the sign of it. So it was positive. If I put 2.5 into this one, then I'm going to have 2.5 minus 3, and that's going to be negative. So when I look at the product of the two, then I'm going to have a positive times a negative, and a positive times a negative is going to give me a negative for this interval here. Okay, moving on to this one, I said 4 was my test point, so if I plug 4 into this first one, I'm going to get a positive. If I plug 4 into the next one, I'm also going to get a positive. And we know that a positive times a positive is going to equal a positive. Okay, so what we've done is we've determined whether the intervals are positive or negative. A lot of times they will alternate. That's not going to happen every time. So be careful about assuming that they alternate. Okay, we want to choose the appropriate intervals, positive or negative, based on our problem. So when I look back up here, I see that I'm working with less than. So less than indicates that I'm looking for my negative intervals. Okay, so my negative interval is this interval here in the middle. So my answer is basically going to be from 2 to 3. And this is where I need to do this last step here, and I need to be sure to closely consider whether the endpoints are included or not included. Okay, because this is a less than or equal to, my endpoints are actually going to be included. So I'm going to have brackets on each of these. And the reason being, if I were to plug in either 2 or 3 into my back into my equation up here, my inequality, I would get 0, and 0 is acceptable because it has this line underneath it. If it were just strictly less than and not less than or equal to, then I would have had parentheses on my final answer. So those are the steps that you go through. Hopefully you kind of see the flow of it after we get started with it. It's not difficult. And like I said, it is a concept that's used a lot in calculus. So understanding these cut points and test points and how it affects the intervals is very, very important. Okay, so this is just a screen where it's written out maybe a little bit clearer. I did want to talk through it and go through our problem that we had there. I wanted to mention that it is possible to do these using your calculator, although I don't necessarily recommend that as the best method. But I did want to kind of show you the association between graphs and what we're doing algebraically here. If you were to look at these using the calculator method, you would still, the first few steps are going to be the same. You'd get all of your terms on one side, you'd factor, you'd find your cut points, and then it's here at step 4 that it would differ a little bit. You'd want to enter your equation in the calculator, and then based on whether it is a less than or greater than problem, you would look for where it's either above the x-axis or below, and then determine your intervals and write your answer from there. So if we look at this one that we just did, we know that when we pulled that over, we had this inequality. So this is what you'd want to enter in y1 on your calculator. So go to your y equals screen and enter this as your inequality. It's going to bring up a graph like this. I would recommend going ahead and zooming in on this part here. If you're having any trouble using the calculator with like zooming and so forth, or changing your window, just let me know and I can help you with that. But here, this is actually 2 and this is 3. And if you recall, 2 and 3 were our cut points. They were where they divided our intervals here, and this is supposed to be a straight line. Okay, so it kind of divides it up. You've got this interval, and then you've got this interval, and you've got this interval. So we can see that here, my graph is above the axis. So this would be like a positive. This is below the axis, so it would be a negative. And then this is above again, so it would be positive. So the cut points cut it as to where the graph is either above or below the axis. So again, we're looking at the less than part. So less than tells me I need this negative region. So it's going to be, again, the part from 2 to 3. So we're going to get the same answer. This is just visually what we're seeing when we do all the plugging the test points in. Okay, I have a series of practice problems that I want to go through. I would say try these on your own a little bit and then kind of see what we've done with them. Okay, so on this one, we want to start out by getting everything on one side, and then we want to factor this. So we'll have 2x and okay, so we get 2x minus 1 and x plus 1. Okay, so to find the cut points, we're going to do 2x minus 1 equal to 0 and x plus 1 equal to 0. So we'll get 2x equals 1. So x is going to be 1/2 as one of our cut points. And x is going to be negative 1/2 is the other cut point. So when I look at my line here, I've got negative 1 and I've got 1/2. So this interval is going to be from negative infinity to negative 1. This will be from negative 1 to 1/2. And this will be from 1/2 to infinity. Okay, so if I pick a test point for this, my test point might be negative 2. A test point here might be 0. And test point here might be 1. Like I said, try to pick numbers that are fairly easy to plug into your intervals. So we're going to plug it into the factor. So one factor was 2x minus 1. One factor was x plus 1. And then we're going to plug it into the product of those. All right, so if I plug this negative 2 in, I'm going to end up with a negative and also a negative. So a negative times a negative is going to give me a positive. Here, if I plug 0 in, I'm going to end up with a negative and a positive. So I'm going to get a negative for that answer because a negative times a negative gives me, a negative times a positive gives me a negative. If I plug 1 in, putting 1 into this factor, I'm going to end up with a positive, and a positive is going to give me a positive. So it just so happens that this one has the same positive, negative, positive that the last example did. Doesn't happen all the time. Okay, this one we're looking for greater than or equal to. So greater than or equal to tells me I'm looking for the positive regions. So this would have been one positive region and this would have been another positive region. So I'm going to do from negative infinity to negative 1. And because it has this equals here, I'm going to put a bracket. I'm going to union that with this other interval here that was positive. And again, I'm going to put a bracket. Remember, infinity and negative infinity never get brackets. They always get parentheses, okay? But I do need on these numbers to actually go in and put the brackets, and then I want to union the two intervals together. Okay, this is the graph for that one. You can see this is the cut point here. This is the cut point at -1, and this is the cut point at 1/2. So this is the positive, and this is the negative, and this is the positive. And you can see that that's kind of where we get it divided here. And we have the positive region and the negative region that corresponds. Okay, here's one that is not quadratic, but I will say it's solved exactly the same way. This one is already factored and it's already got everything on one side and 0 on the other side. So actually our first couple steps are done for us. We just need to figure out what our cut points are going to be. So for the cut points on this one, we're going to set each factor equal to 0. So this counts as one factor. This counts as another factor. And then this counts as a third factor. And we actually don't really need to consider this squared here. It's not going to affect our problem. Okay, so we just really need to look at these factors. So this one would be 0, this one's going to be 1, and this one's going to be 3. And obviously, as you get more proficient at this, you can look at it and see that your cut point is going to be 0, 1, and 3. You don't have to always do this part here. Okay, so we've got a cut point at 0, a cut point at 1, and a cut point at 3. On this one, that divides it into 4 intervals. So our first interval here is negative infinity to 0. This one is 0 to 1. This one is 1 to 3. And this one is 3 to infinity. So for a test point here, we might use -1. This one we might use 1/2, maybe 2. And a test point here might be 4. Okay, so we've got to plug into x. We've got to plug into x minus 1. This is where we do need to consider the square. So x minus 1 squared, and then x minus 3, and then we're going to look at it all together. Okay, this first interval here, if I'm plugging a -1 in, I'm going to have a negative. Here I'm going to have -1 minus 1, but all that's going to be squared, so that's going to be positive. If I put -1 in here, I'm going to have -1 minus 3 is going to give me a negative. So when I consider it all, a negative times a positive times a negative is going to give me a positive for this interval, because I have an even number of negatives. If I look at this one with the 1/2, if I plug 1/2 in, I'm going to have a positive. This one is always positive because it's squared. And then a 1/2 minus 3 is actually going to be a negative. So this one's going to be a negative because I have an odd number of negatives. If I plug 2 in, I'm going to have a positive. This one's always positive. This one's negative, and so I'm going to have a negative here. And then on this one, if I plug 4 in, I'm going to have a positive, a positive, a positive, so my interval is positive. So this is one where I don't have it alternating. One thing that you'll notice is when you have a factor to an even power like this, you're not going to have an alternation of signs around that. So that is going to happen pretty regular and be a pattern that you'll see. So this one I'm looking for less than, so that tells me I'm looking for the negatives. So these are my two negative regions here. So I need to include this and I need to include this. So basically from 0 to 3, the question becomes, do I include 1 or do I not include 1? On this particular example, I am not going to include 1 because if I did include 1, all of this would then equal 0, and it can't be equal to 0. It needs to be less than 0. So my interval is actually going to be 0 to 1, and then I'm going to union that with 1 to 3. So essentially, it's everything between 0 and 3, but it does not include the 1. Okay, so this is the graph for the one that we just got through looking at. So here's the cut point at 0. Here's the cut point at 1, and here's the cut point at 3. So what you notice is it actually crosses at 0, it comes up and touches at 1, and then it crosses at 3. In chapter 3, we're going to talk a lot more about the behavior of this, but here we have a positive region, a negative region, we have another negative region, and then we have a positive region. So these are the parts that we want to consider. And you can see here it actually does touch at 0, and that's why we don't want to include 1 as part of our answer. Okay, we have a series of other ones to practice with, so practice with as many of these as you feel like you need to. Here are cut points. If I'm looking at this and set this equal to 0, I'm going to get a cut point at -3, I'm going to get a cut point at 2, and a cut point at -5. So when I put this on my number line, actually we'll do -5 first. Do make sure that you have these in regular number line order here. Okay, so this interval would be -5, negative infinity to -5. This will be -5 to -3. This will be -3 to 2. And this one's going to be 2 to infinity. So my test point here maybe is -10. This one would be maybe -4. This one will include 0. And this one, let's just say 3. Again, you can pick different numbers. These don't have to be the same with that. So the first interval we have is x plus 3 squared. Then we have x minus 2, and we have x plus 5. If I plug anything into this squared term, this squared factor here, it's going to be positive. If I put -10 in here, I'm going to have a negative, and then -10 plus 5 is going to be a negative. So an even number of negatives makes this region positive. So that's for the x plus 3 squared times x minus 2 times x plus 5. Okay, this region here, if I've got the -4 that I'm plugging in, again, this is positive for everything. -4 minus 2 would be a negative. -4 plus 5 will be a positive. So I have an odd number of negatives, so this region is going to be negative. If I plug 0 in, this one's positive. This one will be negative, positive. So I end up with a negative. And here, if I plug 3 in, 3 it's going to be positive. It doesn't matter really what, because it's a squared factor. If I put 3 in here, this is positive, this one's positive, so I end up with positive. So looking at this, I want greater than or equal to, so that tells me I need the positive regions. So I have a positive region here, and I have a positive region over here. So that's going to give me this interval and this interval. So I'm going to have negative infinity to -5, union that with 2 to infinity. I look back and this does include the inequality. It does include that to be equal. So I'm going to go and I'm going to switch these to brackets to account for that. And that's going to be my answer. I'm going to rewrite it a little neater here. Okay, so our final answer is going to be negative infinity to -5, union that with 2 to infinity. And I almost forgot one thing that we do need to go back and include. This is a little bit tricky on this problem, and that is that there is one other value that actually will make this equal to 0. So we picked up the 2 and we picked up the -5, but actually at -3, the point itself, not these intervals, just the point itself, it actually makes it equal to 0. Because if I plug -3 in, I get 0 for this factor. If this factor is 0, it's going to wipe out the rest of this. So I'm actually going to also include -3 as a point, not as an interval. Okay, this is the graph on this one, so you can see where we have it. This would be the -5, the -3, and then the 2. You can see it actually touches at all of these, and that's why we have to go back and pick up that 1 point. We wouldn't have had to do that if it hadn't had the bar here. If it just had been greater than, then I wouldn't have to pick up the 3. Okay, here's some for you to try on your own. This first one is linear. So we will just try to get all of our x's on one side and the non-x's on the other. So we'll subtract x. So we'll have negative 6x is less than, we'll add that, and that'll give us 9. Divide by negative 6, and so x is going to be, we need to switch our inequality, so it's going to be greater than negative 3/2. So we'll come down and graph that. This is negative 1.5. So that's going to put us here. And we want it to go in this direction. And our interval is going to be negative 3/2 to infinity. Okay, for this next practice one, you want to subtract 4 from each side, and then you're going to end up dividing by 2. Keep your inequalities. Notice one is less than or equal to, and the other is just less than. So when we come down to write our answer, you're going to have a bracket on one and a parenthesis on the other. Okay, here's another one for you to practice. If you'll pause it and then check your answer. Okay, so here's our answer on this one. Our cut points would be 1 and negative 6 by setting each factor equal to 0. That divides it into these 3 regions. So I chose my test points here and plugged those in. And when I plug those in, I find that this region is going to be positive, negative, and then positive. It's less than, so I need the negative region. So my negative region is this one in the middle from negative 6 to 1. So my interval is from negative 6 to 1 with parentheses. Okay, here's another one to try. Okay, here's the answer to this one. This one would factor, so we want to factor it and then set each factor equal to 0 to get our cut points. We put our cut points over here. It's going to divide it into these intervals. And we pick our test points and we'll plug those in, and we find that the first interval is positive, second interval negative, and the third interval positive. Because this is greater than or equal to, we actually want to take all the positive regions. So that would be the first one and the third intervals here. So the first interval is negative infinity to negative 6, and we do want to include the negative 6 because of the bar underneath here. And the negative 4 to infinity, again, include the negative 4, and then you'll see your graph for it here. Okay, here's another one to practice. Okay, on this one, you first need to take everything over so you have 0 to compare it to, then factor that and find your cut points. We'll put those 2 cut points on the number line and set up our intervals and our test points. And then with these, check those, and we end up with a positive interval, a negative interval, and a positive. Because this is a less than 0 here, we want to choose the negative interval, which is this one from negative 3 to 8. And these are going to be parentheses because this is a less than here. So we'll graph that, and you'll see what the graph looks like here. Okay, this is the final one for today. It is just another one to practice with, so go ahead and try this one. Okay, check your work on this last one. You would find your 2 cut points to be negative 7 and negative 5. You'll put those on the number line, choose your test points, and based on the intervals that you have. And when you plug in, remember, because this factor is squared, it's going to stay positive for all the intervals. This one, it is negative and then positive. So overall, we're negative, negative, positive. This is a greater than problem. So because it's greater than, we need the positive region. So that's going to be this last region here. And this is going to be our answer. When you go to graph it, you're going to graph it from negative 5 all the way out to infinity. So hopefully all of these examples have clarified any questions that you may have had, but feel free to join me for office